Okay, so let's continue with talking about the levels of measurements. Remember, I talked about before nominal, ordinal, interval, and ratio. So those are very, very important terms that we would need to measure our data or to make our data make sense to the world. Alrighty? So, nominal, like I said before, is a categorical labeling. Ordinal is the order that in which the data lies. An interval is the appropriate space that cannot be changed once it's determined to for data. And of course, ratio is the most important one because it gives you what is called a true zero. We talked about being dead. That means you are not breathing. So it gives you what is called a true zero. Alrighty. Then, of course, it's important for us to have descriptive statistics. And that will describe, like one of your classmates said before, will describe how the data falls. Okay? So we have the first one is called frequency distribution, and it's how frequent something falls in the data. Alrighty? And central tendency we talked about. Remember, we talked about the mode, medium, and the other one, the three M's, not the singer, not M&M's, but the mean, the mode, and the median. Okay? And each one of those play an important role when we formulating data. Variability means how far apart numbers fall from the standard deviation. Very important. We also talked briefly in class about the different kind of variants that we will find. We call them bivariant descriptive statistics. And that is just telling us that if we get a bivariant descriptive statistics, it will have two curves, bivariant, two variables. And so therefore we have to find out which one of those variables are causing the problem. And then we talked about inferential statistics, how we infer data, if you may. And so one thing I don't think I mentioned in class, but I do want you to know, when we talk about parametrics, we have two types. We have the non-parametric and just parametric. Non-parametric just means that it is not randomized, and parametric just means that it is randomized. Yeah, I don't think I talked about that. The bivariant statistics includes information such as the type of test that we will be using. So when we talk about the statistical analysis or the test, we are then talking about the different types of statistical tests that we use to measure the data. So we gave the definition for the t-test. Please know that it's the difference between two means. So you can use that for two groups, group A, group B. And then you're going to look at the difference between A and B. We also have the analysis of variance, which look at the difference between two or more variables. So you want to know the difference between A, difference between B, difference between C. And of course, we talked a long time on the chi-square. And the chi-square is unique unto itself. In order to understand this test, you have to have two variables. One is expected variable and one is observed. So those two has to be charted on what we call a contingency table. That contingency table will give us some number that will lead us to understand what the variation between what is expected and what is observed. I talked to you very briefly about effect size. I did leave that in the test, but I still have time to change it. But the effect size is the kind of significant difference you want to make when you're doing something. So, such as if you want to change a protocol in the nursing home, you don't want to go, it's gonna work in 100%. You want to give it a modest amount. So the effect size could start from 10. I want to make a 10% impact in what we have and what I want to change. If we change it in 10%, then we can further do more of this change intervention to get a bigger effect size index. Remember the two keys word that we use in measurement: reliability and validity. You must just know those. There's no ifs and out. I've given you keywords for that, so you just have to remember and do that right. The key term that we must try to do when we're doing any research or interpret any kind of finding is how we go about evaluating statistical significance. And one of the things that we must always look for is the credibility and the validity of the research. We need to look for biases. We need to look for other people who has done similar research that can corroborate what we are saying. Okay, I think I covered everything. I am going to, because I can't get to my computer, I'm going to check to see what else we can go over. And that's pretty much it. Remember, we talk about the bell curve. Don't forget to understand what degree is under the bell curve. So the bell curve, according to Mr. Abraham, should be 100%. However, because he states that no one is perfect or no solution is perfect, guess what he says? That on the very end of the bell curve, there could be a difference or a variation. So he believes that things are 99% by taking away the DF. So you would have to close the bell curve. If you close it 50-50, it should be 100. But based on his equation, it should never be, because there's always biases. There's always something that will change the outcome of that bell curve. So according to him, the first two parts of the middle of the bell curve has a number that will give you 68%. All right? And those are the two inner part of the bell curve, and that will give you 68. As you go out further, it's going to be a little different. So therefore, the bell curve will determine where certain data falls in your statistical analysis, if you may. The other outer portion from the standard deviation That number, I believe, is 13.6. It varies with different textbook. I've seen 14 there. I've seen different numbers. But the standard way that you want to look at it is really to just say 13.6. So he does the equation, the founder of this bell curve, to equate it that it will never truly be 100%. All right? When you are on the third standard of the deviation, you will have what is called a 95%. So that's including all three parameters, both the negative side and the positive side, to equate the statistical difference of the bell curve. Alrighty? Okay. Oh, I think I said that before, but just in case I don't, because I still get confused with this. The bell curve has two directions. One to the left is going to be, the left is going to be positive, and the right is going to be negative. We talked about directional things. Is when you're asking a question about the coefficient of the data, you must look at the number, not the sign. The number that changes is the one that you will be analyzing, because a negative and a positive are what? Equal. They're both 0 to 1, but going in different directions. Alrighty. I think that's about it. I don't, because I can't get on my computer, I can't look and see what I wrote down for the study guide. But if you know, if you answer the question, and if I ask someone to send it to me, if I'm able to do another little taping like this with specific outline and definition, I will call you back. Right now, I'm not able to get on my computer because my phone in Dubai is not working. And so as a result of that, I can't get that very famous number called the MF. This really makes you want to say some bad words. The MFA. However, what I will do, I will wait for them to send me access to my what is it called, Brightspace, and then I'll send it to you. All right? So I hope you can start studying and do the best you can. Bye-bye.